In this series of videos, we're going to continue our work with algebra. We're going to look at polynomial division, or, if you like, algebraic long division. We're going to look at the factor theorem and the remainder theorem. To begin with, in this video, we're going to go over a bit of revision on simplifying algebraic fractions. So, in the first question, it says simplify the following algebraic fractions. So, in question A, we've got x squared plus 2x, and that is all over x. Couple of different approaches to this. We could simply say now that we're going to divide through by x. Alternatively, we can split this fraction up by splitting the numerator. So I can actually write this now as x squared over x plus 2x over x. This is exactly the same as saying if we had, for example, 6 over 7, we could write this now as 2 over 7 plus 4 over 7. All I've done is simply now split the numerator. We've got x squared divided by x using rules of indices. We've got now the 2 minus the 1, which will simply give me x to the first power. We've got now 2x over x. You can either see this as the x's cancelling or subtracting the powers. 1 minus 1 is 0. So we would end up with now 2. So this now is the simplified fraction that we get from dividing x squared plus 2x by x. So lots of different approaches. We used this particular method when we were dealing with calculus. So for example, if we were differentiating or integrating, we used this particular method as we were yet to use advanced techniques to differentiate or integrate. With this one here, again, I'm simply going to split it up. We've got now 2x squared, and we can write that divided by x. So let's just put that as a 2. We've got minus 3x divided by x, plus now the 5 divided by x. If we have 2x squared divided by x, the x will cancel now to simply give us 2x. We've got minus 3x over x, which is going to give us minus 3. And then we're going to have now plus 5 over x. An alternative method here is to simply say I'm going to now multiply through by x to the negative 1. If you do that, it will simply cancel off the fraction and we will divide using a slightly different explanation at least. So that is now split up. So we simplified, and if we wanted to integrate or differentiate this, we could use now a technique that we've learned. We're yet to look at integrating where we have 1 over x, but again, we will study that in a later unit. That's got no real relevance to what we're doing here. Okay, if we now look at the next fraction, we have a factor of x minus 4 in the denominator. With these particular ones, we would look to factor. So if I look now at the quadratic factor in the numerator, we could factor that, and we could write that now as x minus 4 multiplied by x plus 3. So we're moving on very slightly, and now we've got the x minus 4 in the denominator. We can cancel common factors. The common factor is the x minus 4, and that would simply now leave us x plus 3. This is what we call a linear factor, as we've got now x to the first power. Or you could say that the degree is 1. Here the degree is 2, and here the degree is 1. That's the power, the highest power on x in the polynomial. Okay, if we look at the next one, we've got here 2x squared minus 5x minus 12, and in the denominator 2x plus 3. So we're dividing a quadratic by a linear term. I think this is going to factor. And if we factor the numerator, we'll have 2x plus 3, and we will have now x minus 4. So we learned how to factor quadratic expressions in a previous unit. So if you need to check that out, please do. And that will now give us 2x plus 3 in the denominator. These are common factors, so we can cancel them. And that's simply going to leave us now x minus 4. Let's just check that. If we did this, we're going to get 2x squared minus 8x plus 3x minus 12. So that now is our final answer. So we can say when 2x squared minus 5x minus 12 is divided by 2x plus 3, we get now this value of x minus 4. We call this a quotient. That's what we get as a result of dividing now one polynomial by another. Okay, let's look at this one here. Now this one is 4x squared minus 25 over 2x minus 5. Hopefully we can spot this as a difference of two squares. Often in this case we'll be given a clue in the denominator. So the clue here was that 2x plus 3 is now going to be one of the factors of that quadratic. So factoring the numerator, we're going to have now 2x minus 5, and then we're going to have 2x plus 5. That's the difference of squares in the numerator. If we expanded it, we'll get 4x squared plus 10x minus 10x, with the 10x's cancelling, minus 25. So over 2x minus 5, and we can simply cancel off the common factors. What we can't do, for example, here is just start cancelling off and saying, well, we'll divide the 25 by the 5. We can't do that. We must factor. Okay, so all we're left with on this one now is the linear factor of 2x plus 5, and that is our final answer. Okay, the next one, again, we have a difference of squares. A squared minus b squared is a plus b multiplied now by a minus b. That is going to be over two lots of a plus b. The a plus b's are the common factors, and that simply leaves us now a minus b divided by 2. Now you could argue that you could write this as a over 2 minus b over 2. I think as a fraction, a simplified fraction, it actually looks cleaner like so. So there's a bit of revision on essentially dividing polynomials. In the next couple of videos, we're going to look at some alternative techniques when we have different scenarios with polynomials. But this should have just been a basic bit of revision on either splitting a fraction up or factoring and cancelling down.